Alrighty, let's see. Remove covered intervals, medium. Given an array intervals, where intervals is left, right, represents inclusive the starting, exclusive of the ending index. Remove all intervals that are covered by another interval in the list. The interval AB is covered by interval CD if and only if C is less than or equal to A and B is less than or equal to D. So they have to be, so like AB has to be strictly kind of in the region of CD. Remove all intervals that are covered by another interval in the list. Okay, technically, I guess if they're exact same, then they're the same, so you can remove duplicates, but the order doesn't particularly matter because we're talking about inside another interval. So like, let's see, so 3, 6 is then 2, 8, so remove 3, 6. And 1, 4, and 2, 8 are not removed. And that's two things that remain. Okay. Seems simple enough to understand. So it has to be in between another one. This seems like a monotonic stack in some fashion. Monotonic. Wonder if I want to sort. I think I want to sort, right? I think I want to sort because I really want to go through kind of the smallest starting index before the biggest ones. And wouldn't make sense for me to like see the biggest, let's say there was one that was like 1 to a million and see that as the very last one. And then at that point, kind of backtrack through all the previous intervals to see that it works to remove them. So I think, yeah, it's a sort first. And then what? I think I need to track ending indices somehow. Iterate over the starting indices from an ascending order. Keep the largest ending index seen so far. Yeah, so I iterate over the indices in ascending order. So it's like 1, 4, 2, 8, or iterate over the intervals. So 4 would be kept here because 4 is the biggest ending index, and then 8 is bigger than that. So I can discard 4 because 4, whatever interval is ending with 4 is not gonna kind of remove 2, 8. But then with 2, 8, I know that when I see a 6, that can be removed because the starting index is going to be strictly greater. Actually, it looks like, let me double check here. I think I don't want it to be sorted. I think I want it to be sorted ascending on the first index, but descending on the second, because I want like, if there was like a 2, 6 here, I want that to be done I guess I could probably figure out a way to do it without sorting on the second index. But I probably yeah, it should be sorting on the I can either sort in reverse order for the second value in the interval. Okay. So key equals lambda x. So specially defined where lambda x is going to give me x0 and negative x1. This just means that for every x, which is an element in the list of intervals, which is the two-element array, I'm going to treat that two-element as the same for the starting index, but reverse for the ending index, or negative for the ending index, so that it does the second index in reverse order. Okay. I'll just double check that this is working. So I'm going to check that 2.6 comes after 2.8. So it should be like 1, 4, 2, 8, 2, 6, 3, 6, yeah. Okay, and then I'm going to use the monotonic stack. Or is this monotonic stack? Maybe it's just, no, it's just keeping track of the highest, thing. I'll do a remove count, I guess. High is equal to 0, maybe intervals. Man, I thought, is there no ad blocker in this? I need to install an ad blocker in this Chrome. Yeah, I'll start with 0. So for every index, or just for every interval, maybe? Yeah. Let's go A, B as interval. Let's do if, I guess I really don't need to know A actually. So if it's the high is higher, then it needs to update. Then high equals B, else. I think that means I just removed this item. And then return, I guess it should be length of intervals minus however many I remove. I think that's it. Okay. Okay. 1 millisecond. Wonder if I can do this. If I didn't do the special key for sorting and had it ascending sort, then I would have to do some sort of logic checking if the first value is the same somehow. It's whatever. Okay. Summary. So, so what is the overall idea here? So pretty apparent that it's most effective to sort the array, the intervals array, um, in order to process the intervals from smallest starting to largest starting, where the interval is the starting comma the ending index. When iterating over those sorted intervals, keep track of the highest ending interval. Any later interval whose ending is equal to or smaller than that highest must be within the scope of a prior interval, or within the kind of, yeah, within the bounds of a prior interval, which will be removed, because obviously the starting index is strictly greater than, and then the ending index is strictly less than, or not strictly less than equal to the ending index. So therefore, it has to be inside. Keep track of that remove count, and then return the remain count as the length of the array, or the number of intervals minus the remove count. Also note, we'll sorted the intervals array using ascending sort on the starting and descending sort on the ending, in order to uh, not worry about like situations like, let's say, 1 or 2 8 and then 2 6. Like in theory, if you do ascending sort for both the starting and ending index, it'd be 2 6 before 2 8. But then you wouldn't be able to leverage the fact that 2 6 should theoretically be in the scope of 2 8, and you need to process the 8 before the 6. Anyways, so that's this special key sorting. Time complexity, this can be O of n log n. Then the array needs to be sorted first. The processing of the sorted array is O of n, since we're doing constant work iterating over each interval. Space complexity, this can be O of, technically, I mean, we kind of used temporary thing here. I'm going to say this is probably O of 1, since no extra space is needed. I don't think using a key is technically creating a new array of size n for this. So, okay, cool beans.